Hi, my name is Dr. Samantha Lawler, and I'm an astronomy professor at Campion College at the University of Regina. I'm making a video it's directed at students, probably like kindergarten to grade 6 or so. But anyone who's interested in learning a little bit about how cool our solar system is, some interesting facts about the planets, and a little bit about exoplanets is welcome to watch. There's an optional activity that I'll suggest at the very end of this. So if you'd like to participate in the activity, please have a piece of paper to draw on and some drawing materials, crayons, pencils, whatever you'd like. I will hopefully give you enough information that you can create your own exoplanet system at the end of this lecture. Thanks for watching. I hope you enjoy. So this is our solar system. We have the sun. There's 4 rocky planets that are in close to the sun, and 4 larger gas giant planets that are farther away from the sun. They're not actually this close together. They're so far apart that we would have, if we tried to fit it on the screen, they'd all be like less than a pixel. So this is a nice drawing just to show you the relative sizes of the planets, right? So you can see that Earth, the planet that we live on, is pretty small compared to the gas giant planets, but it's bigger than the other rocky planets, and the sun is much bigger than everything. So the closest planet to the sun is Mercury. It looks a lot like Earth's moon that you can see in the sky, right? There's no atmosphere. The surface is covered with craters from asteroids smashing into the planet in the distant past. There was a space probe recently called the Messenger mission that took amazing pictures of the surface and learned about Mercury's magnetic field. The second planet from the sun is Venus, and despite being farther from the sun, Venus is actually way hotter than Mercury, and that's because it's covered with this very thick atmosphere, right? So you can't even see the surface if you were to look at Mercury with your eyes or with a telescope. You need to use other types of light, so colors that your eyes can't see, in order to see through the clouds and see the surface. So if we could look through the clouds, so this is using radar measurements, so reflecting radio waves off the surface and then capturing those radio waves with an orbiting space probe, and that tells us about what's underneath the clouds. So you can see Venus has there's no oceans, there's no ice caps, right? It's just rock. There's a few structures that are maybe volcanoes, but we don't know for sure because it's so hard to study. So another reason that it's so hard to study, so I mentioned its atmosphere and its super high temperatures. So this is one of only a couple of space probes that actually managed to land on the surface of Venus, and they only broadcast for a couple of hours before they got squished and melted and burned, basically just completely flattened by the atmosphere. The atmosphere is so thick that it's like being about a kilometer underwater, right? Like down in the ocean, there's that much pressure pushing down on you. And the temperature is hotter than your oven can get. So it's a pretty nasty place. Also, on top of all that, it rains sulfuric acid. It is just not a very nice place at all. So these are the only pictures that we have of what the surface looks like. But you can see Venus in the night sky, right? Venus looks like a really bright star. And sometimes it's visible in the morning and sometimes it's visible in the evening. And it's really easy to see because it's the very thick clouds reflect a lot of sunlight. This is our favorite planet, right? Everybody loves Earth. It should be everybody's favorite planet because it's the only one that we can live on. Earth is very different from all the other planets in our solar system. When you first look at it, you can see it's blue, right? It's mostly blue and white. It's covered with it's not completely covered with clouds like Venus, and it's not completely bare like Mercury, right? There's some clouds you can see through to the surface in other places, and most of the surface is covered with liquid water. So Earth is the easiest planet to study because we're standing here on it right now. So we know it has mountains, it has weather patterns, different types of clouds, it has rivers, it has erosion, different landforms happen because there is liquid water on the surface. We have ice. Our temperature's just right that we can have liquid, solid, or water vapor at different times of year and different conditions in different parts of the planet. And that's really, really special because that makes it easy for life to be here on Earth. Earth is the only planet that we know for sure has life on it. And we have a stunning array of different kinds of life, right? We have plants, we have single-celled organisms, we have weird thing, like every possible habitat that we've measured on Earth has things living in it, right? There's worms that live kilometers under the ocean next to volcanoes. There's herds of animals that live all over the planet. There's bacteria that live in rocks a kilometer down in under the ground, right? Up in the air, everywhere there's life. And of course, we're here, right? Like lots of different humans live on this planet. So the next planet out is Mars. Mars is so when you look at the surface, right, it looks very different from Earth. There's no liquid water. You can see a little bit of ice on the poles, right, down here and up here. But there's no liquid water. There's lots of craters. And it's the closest, easiest planet to get to. So we've sent a lot of space robots there, right? There's a new Mars rover that just landed there when I'm recording this about a month ago. This rover, this is a recent picture. So rovers take selfies to sort of check their condition and make sure nothing looks like it's about to break or make sure, so because there's nobody who could help them, right? If something breaks off, there's nobody there to fix it. So they have to be very careful with telling the rover where to drive and just keeping it in top condition, right? So this is one of my favorite pictures ever because it's a picture, if you look, so this is a picture taken by a satellite that's in orbit around Mars, looking down on a Mars rover, right? So a space robot looking at another space robot that's driving on the edge of a cliff on another planet. That's an amazing piece of engineering. So we've gotten very good at sending probes to Mars, and those probes tell us about the history of Mars, if there was liquid water there, which we're still trying to decide if that's true or not. There's definitely water on Mars as ice, right? We see it in the ice caps, we see it under the surface, we see it on the edges of craters, but there does not appear to be any liquid water. There's no liquid water now. Was there liquid water in the past? That's what these rovers are trying to find out. And if there was liquid water there, was there life? That's the really interesting question to me. So, moving further out from the sun now, in between the orbit of of Mars and the orbit of Jupiter, we have the asteroid belt. So this is looking down on the solar system. Here's the Sun, Mercury, Venus, Earth, Mars. And all of these little dots are the hundreds of thousands of asteroids that we know about that are orbiting around the Sun. We've got some really good pictures from space probes of some of these asteroids, right? Some of them look like, funny potato shapes. This one even has a little asteroid moon around it. Some of the asteroids, like, Ceres is the biggest asteroid. It's so big that it looks like a little planet. And a space probe recently visited and took some amazing pictures of it, including this very bright spot in one of the craters that is probably salt deposits. Sometimes these asteroids hit the Earth, right? So there are places on Earth where you can see big craters. This is a crater in Arizona that's about 50,000 years old, and it's a couple kilometers across. So this is a time. So 50,000 years ago, a very big asteroid slammed into the Earth and made this crater. We see little tiny ones all the time because there's a lot more small ones than big ones. So I hope that some of you have seen asteroids, meteorites. When they burn up in the atmosphere, they're when they make it to the ground, they're actually called meteorites. When they burn up in the atmosphere, they're called meteoroids. And that's what most of us have seen, right? We sometimes call them shooting stars. And it's just a little bright streak that you can see just for a moment, and then it's gone. And those are like little bits of sand. They're so tiny. But once in a while, a slightly bigger one will come in, and this is a picture of a car that got hit by a very small meteorite. So no one has ever been killed by a meteorite. No human has ever been killed that we know of. But a few people's houses and cars have been hit by meteorites in the past, but it's very, very rare. So the next planet out is Jupiter, the biggest planet. So Jupiter doesn't have a solid surface, right? If you wanted to go visit Jupiter, you couldn't stand on it. You would just land and fall in, and it would just get denser and hotter, and eventually you'd get squished. So there is a space probe called the Juno mission that is currently orbiting Jupiter. And so you can see, so this is not a computer animation. This is actually real images from this probe sped up, showing what it would look like to fly past Jupiter. And it's just incredible. Like, you can see all these different colors in the atmosphere, all these weird swirls and patterns, and that's different gases, different kinds of clouds that you can see at different layers in the atmosphere. It's just absolutely beautiful, right? And it's huge, right? You could fit like 1,000 Earths inside it. It's so big. So Jupiter is beautiful, but we couldn't live there, right? I love the poles, like just the different colors of clouds and the intricate swirls. It's just amazing. Jupiter also has a lot of moons, and it has a few really big moons. So Jupiter has 4 moons. One of them is so big that it's actually bigger than Mercury, right? And these 4 moons orbit in very close to Jupiter. So Io, the closest one, right? So it looks kind of like a pizza, right? It's very yellow. So it's actually covered with sulfur because it has these huge volcanic eruptions, because it's so close to Jupiter that it gets sort of kneaded and squished by Jupiter's tides. It's pretty amazing. So this is a set of pictures of a volcano on Io that's so big that it's shooting lava like hundreds of kilometers into space, and then it's falling back on the surface. Pretty crazy. So Jupiter currently has 79 known moons, and so the big ones are really, really close into Jupiter, but there are 79 in total, and many of them orbit quite a ways out from Jupiter. And when when you draw all their orbits, it looks kind of like a ball of string. It looks very messy. Next planet out. So I love Earth, but Saturn has these beautiful rings. I love Saturn's rings. Everybody loves Saturn's rings. I hope you all love Saturn's rings. So this is an image of Saturn, where a space probe, this was the Cassini probe, which orbited around Saturn for several years and just took amazing pictures. So this is a picture that the Cassini probe took when the sun is directly behind Saturn. So you can see the rings are backlit by the sun. Over here you can see where the rings are actually reflecting back onto the surface of Saturn, right? It's incredible. It's so cool to think about what that would look like if you were there. So fortunately we have space probes that can give us a little hint of that. So if you could fly a space probe through Saturn's rings, well, you wouldn't really want to do that because it's made of lots of little tiny pieces of ice that are all flying very close to each other, right? So countless pieces of ice, and they all orbit very, very close together, so that it looks like they're so close together that it looks like a solid when you look at it from far away, but it's actually little tiny pieces that are all orbiting together. There's just some totally cool stuff that happens within Saturn's rings. So there are moons that orbit inside Saturn's rings, and they make weird gaps and waves in the rings, right? So this is a moon that it's making like waves. You can see shadows from where it's orbiting and creating these waves on the surface of the rings. And there's other moons that orbit and keep rings in a really narrow band. And then you get these weird spoke patterns that form sometimes, and that's just because of little ripples in the particles that are all orbiting together. It's just really incredible stuff happens inside Saturn's ring. Saturn has actually the most known moons. It has 82, even more than Jupiter. More are being discovered all the time, so we don't know how many they actually have, but we know for sure that it has at least 82 moons. And one of its moons is really big and has an atmosphere. It's the only moon in the solar system that has an atmosphere, and that's really interesting. We like having an atmosphere, right? We need air to breathe, right? So what does that mean for this moon? And so because it's so far away from the sun, it's much, much colder. When the Cassini probe took pictures from certain angles, you can actually see that there's also liquid on the surface underneath this thick atmosphere. But it's so cold, this liquid is not water. It's methane and ethane. So it's like gasoline. It's like the entire planet has gasoline lakes. It's really, really strange. You don't have to worry about it catching on fire though, because there's no oxygen. So it's like a planet that's covered with weird hydrocarbon lakes. And it has a thick atmosphere. Its atmosphere is actually about twice as thick as Earth's atmosphere. So there's actually a probe that's going to be sent there in a few years that has a little, well, it's not very little, a large drone. It's called an octocopter. It'll have 8 little helicopter blades, and it's going to land and learn about one little spot on Titan, and then it'll fly to another part of Titan and learn about that, and then fly to another part of Titan. So that's going to be really cool. We're going to learn a lot about a moon that's so weird that it has gasoline lakes. Saturn also has another moon that has geysers that shoot water into space. So astronomers think that what's happening is there are volcanoes underneath hundreds of kilometers of ice that melt underneath, and then that pushes water through the ice and out into space. So moving further from the sun, the next planet out is called Uranus. A lot of people say Uranus, but astronomers tend to say Uranus. And it's tilted sideways, right? So instead of being pretty close to spinning in the same direction that it orbits, so Earth is tilted a little bit, right? That's why we get the seasons. Uranus is actually tilted all the way over to one side, so it has crazy extreme seasons. It's another gas giant planet, so you couldn't stand on it. But if you could, there would be really crazy seasons there. And then the most distant planet from the sun is Neptune. So Neptune is another gas giant planet. It's very cold, and it has several moons that have been discovered. One of them is huge, and it orbits in the opposite direction from all the other known moons. This one's called Triton, and it's covered with what's called cantaloupe terrain. Like, it kind of looks like a cantaloupe, and astronomers think that it might actually be captured from further out in the solar system. So those are all the planets, but what's beyond that? So there's little Pluto, right? So Pluto, when I was a kid, Pluto was considered the 9th planet, but Pluto, actually, there are many other objects, we call them Kuiper Belt objects, that orbit the sun beyond Neptune, that are almost as big as Pluto. So a few years ago, the New Horizons space probe visited Pluto. It just flew past. And it took amazing pictures of the surface of Pluto. So now we know that Pluto has mountains that are made out of ice, and it has glaciers that are made out of nitrogen ice, right? Like the air on Earth is made out of nitrogen, but Pluto is so cold that nitrogen freezes into glaciers. It's crazy. Pluto also has a very thin atmosphere, right? So this is a real picture. This isn't a computer rendering or anything. This is a real picture of what the surface of Pluto looks like. It's amazing to think about. So Pluto is not a planet because there are several other known Kuiper Belt objects that are almost the same size as Pluto. And there are thousands more that are much smaller than Pluto that are on very similar orbits. So it's like the Asteroid Belt, but further away from the sun. So after the New Horizons probe flew past Pluto, it flew past another very small Kuiper Belt object, which is now called Arakoth, and it looks like a snowman, and that's the only one that we've ever gotten to see up close. So we don't know, is that what all of them look like? It's about the size of, a city and its suburbs. It's pretty small as far as, planets go, right? So this is a small Kuiper Belt object. So getting further away from the sun, we have a couple of space probes that have been flying away from the sun for more than 40 years now, right? So the Voyager 1 and Voyager 2 probes, so they've now left the area of the solar system that is dominated by the sun. There's still comets and Kuiper Belt objects that orbit out that far away, but they're not inside the sun's protection anymore. They're not dominated by the sun. So they're going really fast. They've been flying for a long time, right? So Voyager 1, the most distant human-made object ever, is 23 billion kilometers away, and it's moving at 61,000 kilometers per hour. That's really fast, right? So how long do you think it would take if it kept going to get to the closest star? Would it take 8 years? Would it take 80 years? Would it take 8,000 years? Or would it take 80,000 years? Right? That's moving incredibly fast. So how long do you think it would take? 80,000 years, right? So the next star is really far away. Stars are really far apart from each other. Like, it takes a long time to fly through the solar system, but it's so far away to get to the next star. So because of that, we can send probes to all the planets, right? We've done it. But we can't send probes to other solar systems. It would take thousands of years, tens of thousands of years. So we have to use telescopes to learn about other solar systems. So we have telescopes on the ground, on top of mountains. We have telescopes in space. This is the camera that is attached to a telescope, right? It's a really big camera for a really big telescope. So this is what we use to find distant planets. So how many exoplanets have we found? Exoplanets are planets around other stars, right? So these are planets in other solar systems, the ones that we can't go visit because they're too far away. So what do you think? Do you think we've found 4, 40, 400, or 4,000? So as of when I'm recording this video, we found 4,375. So if you guessed 4,000, you were the closest. And we're finding more every day. It's amazing. So now I'm going to show you the best picture that has ever been taken of an exoplanet using a really big telescope. And here it is. So it's a little underwhelming if you're expecting, right? I just showed you a bunch of really amazing pictures from space probes of planets in our solar system. But the best picture that we have of a planet in another solar system, it's just a dot. That's it, right? So this is this is all of the planets that we have pictures of. They're all just dots. We do not know what the surfaces are like. We don't know what it would be like to go visit those planets. We don't know what they're made of. We just know that they're there. So most planets that we know about, most of those 4,000, we don't even have a picture of them. We just know that they're there because of the way the star moves on the sky or because of the way the colors change. So a lot of artists and science fiction authors have thought a lot about what other planets might look like. So I'm going to show you a few pictures, and then I'm going to see if you would like to come up with your own ideas. So here's someone's idea of what standing on a planet in a system that has more than one star, right? There we found exoplanets that orbit more than one star, and maybe this is like a moon of a planet. Here's like a lava planet that's so close to its star that it's melting, and there's 2 other stars that orbit around really far away. Here's an exoplanet that orbits around a really cool faint star, so it's totally frozen. Here's, what it would look like if you were on a planet that had multiple moons and had weird, maybe like on Titan, had weird gasoline lakes. There are planets that orbit in systems that have big dust disks around the stars. There are planets that have been discovered that have huge ring systems way bigger than Saturn's. There's, we don't know what it would be like to stand on these planets. We have no idea, but you can take a guess, right? There's even planets that have been discovered that are so close to their stars that they're evaporating. They're like giant comets. So now, so I would like you to imagine your own exoplanet. So what would your exoplanet system look like? What would it be like to stand on the surface of an exoplanet that you imagine? Are there rings? Are there moons? Are there multiple stars? Are there other planets nearby? Are there asteroids? So now sit down and draw. Think about what the possibilities are, and come up with your own exoplanet system, because really your guess is as good as astronomers.